Alright, welcome to another AQA A-Level Chemistry video. This is the start of the the A-Level Organic exam papers, starting off with Optical Isomerism, and I'll be going through all of them. There's quite a few units in organic chemistry, but I'll be going through all of them. I'll be trying to finish, and then once I've done all of these, I'll be completely finished with organic chemistry in total. So that'll be year one done and exam papers on those, and then organic done and organic year two done, and then all the exam papers for that will be done. This is the first one of them, so once I've done that, we'll be fine. So for today, I've got a 50-minute paper. I'll leave a link in the description to this paper. So I want you to get that, print it out first, try and do it yourself. It's 50 marks, I believe. You know, let me just double check that it's actually 50. I did make sure it's 50 marks, but, you know, counting many marks. 7. I should really revise these papers before actually going and doing them. But, you know, life. I could like a massive donut, but the game is the game. You can't be out here slacking. You gotta be putting yourself in the deep end, innit? Right, 1, and then there is 12 here. Yeah, I was right. 15. Yeah. All right. Let me just rearrange this again so it's like back in. Yeah. So it's 50 minutes. Try and do it, and then if you can't do it, or if there's any other question that you can't do it in, I'll be doing all the questions here in the timed conditions. I'll set a timer here, and we'll get started. So yeah, this is a 50-mark paper, so try and do it in a mark per minute. I know in the exam you get a bit more, but try and aim for a mark per minute is really good practice. So enough of me talking, I'm gonna go straight into it now. So 3, 2, 1, and go. All right. Questions about isomerism with the molecular formula C5H10O. Draw the skeletal formula of a branch chain aldehyde with molecular formula C5H10O. That is optically active. Alright. Oh, that is optically active. Okay. Should have probably said this beforehand. Alright, so the thing I'll look at this, it'll say that. Oh wait, no. It said skeletal formula. So actually, you know what? I'm gonna do this formula first, so then I can just know what I want to draw. Probably should do it here actually. One, 2, 3, 4, 5. Yep, that's got in the chiral center there. So yep, just making sure that's that. It's great. Cancel all this out. Describe how you distinguish between two separate samples of enantiomers of the branch chain aldehyde. If it's an enantiomer, then we would just say expose sample to plain polarized light. Polarized light. Will be rotated in equally opposing directions by the enantiomers. Will be rotated. The keyword is always rotated. You can't say twist or anything like that, or shift. They always like to word rotated in equally opposing directions. By enantiomers, by each enantiomer. Notice how I bullet pointed them to make it clear my points. Makes it easier for the examiner to read. Draw the EZ forms of a structure of a structural isomer of C5H10O that shows both optical and geometrical isomers. So both need to show both. Okay, so first of all, just do this. You know it's going to be something like here. That's not going to be. What if I did this? Okay, and then C. They give you very little space to do. In the real thing, they give you more space to write than this here. Sorry guys, it's just such a small space to write in. Or maybe I should just do it on the top here first, and then maybe that'll make it right. You know what, I'm not gonna waste my time with that. Let's put it here. One, two, three, four. Yes, and I can get 5. No, entagon. E means entagon, so it has to be same side. My bad. No, entagon means opposite in German. Sorry, I was right in the first place. Entagon means opposite in German. So yes, the heaviest sides on opposite sides, and then zusammen together. So I promise in the real exam you'll get much more space to write than they've given you here. There we go. Isomer J is a cyclic and has an ether functional group of COC. Isomer J has only 3 peaks in its carbon-13 NMR spectrum. Okay. 1, 2, and 3. That's fine. Draw 2 other cyclic isomers of C5. Ooh, let me make sure that this is in this. Is that in shot? That's in shot. All right, cool. Draw 2 other cyclic isomers of C5H10O that have an ether functional group. Only 3 peaks in the carbon-13 NMR spectrum. So, okay, so. Okay, all right. What was the other one they had there? Technically, let me see if this one works. Because if I had a cyclic, yeah. There's 1, 2, yeah, it would. Yeah. This one's definitely one of them. One, 2, 3, the other one, same condition. Now the other one, what if I did, they did what? 1, 2, 3. Now what if I put, one here and I put, no, that wouldn't work. That's 1, 2, 3, 4, no. But what if I did, oh no, what if I did this? again, with carbon-13, you're going to get examples like this, so you're just not getting it first time. But that works, wasn't it? 1, 2, yeah, 1, 2. No, that's not carbon there, sorry. 1, 2, 3. Yeah, that's it. I could make that bigger, I guess. That's pretty obvious to see. Make it bigger. They're going to just make it bigger for the sake of just making it bigger, but the examiner should be able to see that. Just so there's no stinginess from any examiner saying, I can't see your answer, prick. Anyway, Pyrrolocane is used, we spent 7 minutes, or actually a little bit more than 7 minutes on that question, so I'll probably hurry up. And then Pyrrolocane is used as an anesthetic in dentistry. Draw a circle around any chiral centers in figure 1. That's a chiral center. I'll probably do that one in pen, because, you know, just make it a bit more clear. That's a chiral center. That's the only one, really. Identify functional group in pyrrolocane molecule. The functional group here, I can see an amide here. You know, actually, I probably shouldn't do that in case they start getting onto me. Amide. This is an amine. This is a secondary amine, so I can say that. Yes. No ether, no ketone. No, that's it. That's not a ketone. That's part of that. But so, keep that. Pyrrolocane is completely hydrolyzed in the human body to give a mixture of products. Draw the structure. Did you guys see that? Actually, I can't really see where my camera from. Yes, you did see that. Pyrrolocane is completely hydrolyzed in the human body to give a mixture of products. Draw the structure of the 2 organic products formed in the complete hydrolysis of pyrrolocane in acidic conditions. Now, I should have put my highlighter with me, but you guys see here, so draw the structure of the 2 organic compounds formed when you split this now. Full hydrolysis, so you're only looking at a condensation bond. So these are all non-polar bonds. You can't do that. This is the only one that I'm really seeing here. That cyanide bond, that's not a condensation bond. That's a addition bond. So, or non-polar bond. It's not polar. This, but this here, because of this carbonyl group here, this amide bond is. So I break away this bond here. So it'll be. And then, what was that one? I'll be going to the mark scheme at the end of this just to make sure that my answers are correct, because this is me not really going, and I just go ahead and just do these questions. One day I will get exposed for it, and one day I will be forced to actually revise some of these questions beforehand and then just show you how I done it. But you know how I do, man. You already know what I do, man. I don't do this sad with thing, pussy thing that these men are on. N and then triple C. I just forgot it's in acidic conditions, so this would have to actually be. My bad. This would actually be NH3. I'll put a plus charge here. For the on the nitrogen there. Can you see this? You can. How about? Alright. Figure 2 shows optical isomers F and G. Isomer F is an active compound in the medicine ibuprofen. In the manufacture of ibuprofen, both isomers F and G are formed. An enzyme is then used to bind to isomer G and catalyze its hydrolysis. After the products of hydrolysis of G are removed, a pure sample of isomer F is collected. Explain how structure feature of this enzyme enables it to catalyze the hydrolysis of isomer G, but not the hydrolysis of isomer F. And as I said before, when I did the enzyme video or something to do with proteins, the active site, sorry, on the enzyme, sorry, that's a terrible. The active site on the enzyme is complementary to it's all complementary to isomer G only. Sorry, bear with me for just a second. I just heard an alarm upstairs I need to just take care of. Yeah, my bad. I'm gonna restart the clock. Active site on the enzyme. So it will only. So it will only bind to the isomer G. And break it down. And hydrolyze, I should say. I should have actually bullet pointed this question actually. The actual point was saying active site on the enzyme is complementary to the isomer G only, and then saying it's only binds to isomer G to hydrolyze it. But there you go. Hopefully you got that point there. That's something that we've done from the previous video. How we doing with time? 35 minutes. Sounds about right. The aldehyde, so and so there. Reacts with KCN followed by dilute acid to form. By the way, if you see that last one, I'll read it again in case you can't see the last one here. So the active site on the enzyme is complementary to isomer G only, so it only binds to isomer G and to be hydrolyzed. That's terrible. That's why you need to reread your answers. Sometimes reread your answers. To hydrolyze it. Yeah, done. Alright, cool. The aldehyde, 2, 3, 4. Pentanal reacts with KCN followed by dilute acid to form a race mixture of the two stereoisomers. Then I'm going. Oh, it says just give the name of that compound anyway. 2. I know it's a 2-hydroxy because you can see this near. So 2-hydroxy. 1, 2, 3, 4. Hexane nitrile. Make sure you put the E after the N here. That's important. Nitrile. For some reason, they deduct a mark if you don't say the E here. So I'll make sure to say that. Describe how you distinguish between separate samples of the two stereoisomers of 2-hydroxyhexanitrile. Like I said before, expose samples to plain polarized light. And Each enantiomer will rotate plane polarized light in equal opposing directions. Equally opposing directions. Explain why the reaction produces a race-mate mixture. Because the cyanide group can attack. Oh, that's not how you spell attack. By the way, in the real exam, don't use this pen and these like robot pen because when you put it under the scanner, it actually causes the ink to evaporate. So you don't want to have that happen. So don't use this pen. I'm just using it for the sake of this, but don't use it in the real exam. All right. So the cyanides group can attack either side of the planar carbonyl group. Producing an equal volume of each enantiomer. Equal volume of either enantiomer of the same chiral center. In a beaker, in a mixture. Yeah, in a mixture. An isomer of CH3, 1, 2, 3, pentanal reactive KCN followed by dilute acid to form a compound that doesn't show stereoisomer. Draw the structure of the compound formed and justify why it does not show stereoisomerism. So, so an isomer of this, okay, so doesn't react with this, but it's okay. So it's somewhere in the middle because they're not going to be on either end because then you could definitely get stereoisomer on that side. And it reacts with the KC, so it would have been an OH now. So see here, 1, 2. Yeah, so 1, 2, 3, 4, 5. And then it's 6. Yes. Yeah, and then here. If I now have, it's not a stereoisomer because now this is the same here. So CH2. This is 1, 2, 3. Yeah, and then now this is it. There's no chiral center here because there's not 4 different substituents. Oh, I was supposed to draw it here. My bad. There's no chiral center. So how do you? There's no chiral center. There's only 2 marks, so it would be marked for that and that. Which pair of compounds doesn't form a racemic mixture when the compounds react? No, that's going to form a racemic mixture. H. Nope. Wait, let me just check out this one here, because that's gonna have the same thing here. Why don't I just go straight to this one? This one looks like much obviously like it's gonna be. Yeah, and then CH3 here, CH3 here. I sometimes, you know what? Sometimes you can just see them. I was just being really silly there. It's very obviously this one here. Just make sure to read through all of them first before giving them a go. Which compound doesn't show stereoisomerism? Doesn't. This one, have a look at this one. So just look at the one that makes the most sense when you look at them. So that. You know it's not going to be those two because that's probably going to have it. You're probably looking at a 1-3 where they're separate apart. So it doesn't show stereoisomerism. So it just hasn't got a. It hasn't got a chiral center. No chiral center here because that's going to be H here. So perfectly symmetrical molecule. So that's going to be a no-go. Can you see? Sorry, did you? I'm just making sure that everyone can see these before I move up. I should have my viewfinder up actually. This question is about isomerism. How many isomers are represented by C5H12? C5H12. So, one is just the normal one we have. I can't do a cyclic because it's C5H12. 1, 2, 3, 4, and then that's 1. 1, 2. And anything else would just be same thing. So 3, I'd say. Name the structural isomer shown by the isomers, a chain isomerism. Two-hydroxypropanitrile displays optical isomerism. Draw a 3-dimensional representation of the 2 enantiomers of the 2-hydroxypropanitrile, showing how the two structures are related to each other. I should have brought my ruler with me. Oh, no, I forgot what it says. Alright, 1 second. You know what? No. Sorry, I had to do this. I should have been more prepared when I got this. My bad. Don't follow me, get an actual ruler. I'm just doing this for the sake of the fact that it's convenient. I should have got my actual ruler upstairs, but yeah, it is what it is now. Times are tough, innit? So the cost of living's going up, innit? Yeah. It's cost of living crisis. Anyway. 2-hydroxypropanitrile. Propane nitrile. 2-hydroxypropane nitrile. Alright, describe how separate samples. Hopefully that made sense. By the way, I should have been talking as I was going through that. I just forgot that I'm not recording. Yeah. Draw your mirror. Obviously, I have shown examples how you do the other ways first, but I suggest doing the mirror line first. And then draw one molecule and make sure the other molecule is a complete, perfect mirror image of the first one. So even where you draw an atom is going to be completely symmetrical to the other way. Describe how separate samples of each enantiomer shape could be distinguished. Again, they're repeating this question quite a lot, but you should know. So expose samples to plain polarized light. The plain polarized light. No, the enantiomers will rotate the plain polarized light. Sorry. In equally opposing directions. Alright, butane 2O reactive concentrated sulfuric acid to produce 3 isomeric alkenes. Name and outline a mechanism to show how any one of the alkenes is formed. Great. Explain how the reaction can lead to the formation of each of these 3 alkenes. Now, okay, I can just see already butane 2O reactive sulfuric acid to produce an alkene. That's elimination. It's not basic elimination, it's just elimination. There's no basis here, so this is just elimination. Alright. That part's already done. Explain how it can lead to each of these 3 alkenes. Okay. Butane 2O. Yes. Going from, so the lone, there's an arrow going from the lone pair on the oxygen atom of the hydroxyl group to the H+. The H+ is obviously coming from the sulfuric acid, which is a strong acid. We then form this small intermediate here. Now I said 3 isomeric alkenes, could be formed, and that's because we've actually kind of formed a hydronium ion, I think. Is this a hydronium ion? No. It's just a water, but it's just bonded to this carbon, and it hasn't quite yet left. So I'm going to show every single Alright, cool. So yes, I'll do it like this. So first of all, this would go back like this. This is going to go here. You form this intermediate quickly. H3C, that. Now, if this carbon, you're going to lose one of the hydrogens from either side, right? You're going to lose a hydrogen from either side, right? I'm going to show you what I mean here. So this is considered to be the alpha carbon, and these are the beta carbons, right? Now, if you go from the right, the secondary one here, so this hydrogen here, this carbohydrate bond here, and you break it off to go here. You've now reformed that, and then you form but-2-ene, but they said free, right? Free isomeric alkenes. This is but-2-ene, but this is let me just finish off. EZ but-2-ene. So technically we already have two here. EZ but-2-ene. Now there's another rep method. They haven't really given me much space to do it here, but you could go and form I'll do it here. You form this intermediate here, where this is the carbon hydrogen on this carbon here, carbon 1. Yes. And now you have but-1-ene. Yeah. Explanation. 15 minutes left. How much? 15 minutes to answer 12, 13. Okay, so I've still got 2 minutes to now do this now. When a secondary carbocation forms, make that specific. When secondary carbocation forms on carbon 2, we could say the alpha carbon. A carbon hydrogen bond. Sorry. If a carbon hydrogen bond on carbon 3 breaks, you form a geometrical isomer of either E or Z but-2-ene if the carbon-hydrogen bond on carbon 1 breaks, I forgot to mention at the start of the video, just go to the questions that you need help with. Don't need to go through every. I probably should have mentioned at the start. Only go through the questions that you need help with. Don't just do these easy questions if you can do them easily. So if the carbon-hydrogen bond on carbon 1 breaks to form double bond, to form a carbon-carbon double bond. But1 will form. I just looked at the time. I should be starting the next question now. Too much talking, but I guess that's what this video is meant to be, me explaining it to you. Which compound forms optically active compound? Did you see that last part in case you didn't see it? Yeah. There. Alright. Which compound forms optically active compounds on reduction? That definitely won't. OHHC. Yeah, that will. That's it. See, you look at the easy ones first, and then you can cancel them out. That's my advice. Hemiacetals and acetals are compounds formed by the reduction of aldehydes of alcohols, such as direction of ethanol. Use your knowledge of carbonyl mechanisms to suggest the name of the mechanism of this reaction. Well, first of all, it's nucleophilic. I can see that. We already know that's going to be nucleophilic addition. Is it addition or elimination though? That's what you need to see. Addition. Which one's, this one's going to be acting as, this is acting as the nucleophile. That doesn't change. So we're looking at the compound that we're trying to change. And there's no change to this compound here. It's only the hydrogen that's lost. A hydrogen is lost, but a hydrogen is lost on this compound, but this compound is acting as the nucleophile. So this is not the compound that we're trying to change. This is the compound that we're trying to change. So in this case, it was just a nucleophilic addition. I'll leave it as that. Outline how an ethanol molecule, and if you can't do that, just do the mechanism. But I'm not going to do that now because of time. Outline how ethanol molecule reacts with ethanol. Actually, they want me to do that here anyway, or part of it. In the first step of the mechanism, include 2 curly arrows, show the movement of the electron pair. So I just want the first mechanism, or the first part of the mechanism, and in which case I will do a SO H3C. Curly arrow here, done. 2 marks will be for each arrow. The reaction produces a racemic mixture of chiral molecules. Explaining the term racemic mixture. It is a compound it's a mixture with an equal volume of each enantiomer. Of the same chiral compound. A mixture of an equal volume of each enantiomer of the same chiral compound. State the relationship between 2 chiral molecules with the same structural formula. The relationship between 2 chiral molecules with the same, they are non-superposable mirror images of one another. Non-superimposable mirror images of one another. As I've demonstrated in another example previously. 8 minutes. How much to do that? 4, 5, 6, 7. Okay, so I have time, a bit of time. So, in the presence of an acid catalyst such as dry hydrogen chloride, ethanol reacts with excess of ethanol to form an acetal. The overreaction of ethanol with an excess of ethanol forms an equilibrium mixture as shown below. All reactants and products are liquids. A mixture of 0.75 moles of ethanol and 5 moles of ethanol were left to reach equilibrium in the presence of a dry hydrogen chloride as at a given temperature. The equilibrium mixture contains 0.42 moles of acetal. Calculate the amount in moles of ethanol and of ethanol in the equilibrium mixture. As I said before, you in your exam don't accept, even if it's a completely organic paper, don't expect some physical aspects to be in your paper. So be aware of that. I just remember when we did KC equilibrium mixtures, we did the ice table. So ice, the mixture 0.7 equilibrium mixture of 0.42 of this. So 0.42 of this. So that means that's 0 here, 0 here, unless it told us. 0.75 of ethanol, 0.75 of ethanol, 5 moles of ethanol. Alright, so that's plus 0.42 here. We know that's plus 0. Minus 0.42. I could just take that away. 3. 7 minus 4. 3. 0.33. This is minus 2 by, because remember there's 2 moles of this compound. 2 by 0.42. That's 84. 0. So 5 minus 0.84. Okay. Just make that 4.16. Should have been able to do that in my head, but I'm tired. It's late. Calculate amount in moles of ethanol and ethanol in this equilibrium mixture. We have that here. Ethanol is 0.33 and ethanol is 4.16. Make sure that's a bit more clear to see. Oh, the space for working was meant to be here. Oh well, it's too late now. I guess we could just do a little here. Probably shouldn't have done that now. I've got it. Still being an idiot like me and not read the questions properly, but you know, hopefully it's try and do the working out where they tell you to do the working out, because otherwise you can do a lot of working out, but if it's not where they want you to do it, they may allow it, but why take the risk? Don't be like CB. Don't always take the risk. I'm trying to sit back, super lean. All right. In a different experiment, using the same reaction as in part C, an equilibrium mixture was established at a given temperature. This mixture contains 0.58 moles of ethanol, 3.76 moles of... Okay, so just giving you a different example. Write an expression for the equilibrium constant Kc for this reaction. Calculate a value for Kc at this temperature. All right, so an expression for this, which that's pretty easy to do. I'm trying to sit fast. H3C, okay, is equal to CH3 C CH. I don't like the fact I left a little gap there. That's not even quite a lot. CH O CH2 CH3 2 and times that by H2O. It's just product over your reactants. You should know this from year 1. CL, okay, ethanol. And the other one was ethanol. But it is squared because it's 2 moles of it. Now doing the actual calculation of it, how much time we've got left? 3 minutes. And okay, 4 minutes. All right, okay, you probably need to hurry up with this now. Okay, I haven't got much time now. moles of acetal. So concentration is equal to moles over the volume. We have the moles, we have the volume. They gave us the volume of 310 centimeters squared. So volume equals 0.31 decimeters cubed. Something over 0.31 acetal water. They'd give you much more space in the real exam, so I don't know why they just done it like this. Okay, so 0.58 was ethanol, so ethanol was 0.58. Ethanol is 3.76. How much time have I got left? 2 minutes. 0.37 was acetal. Water was 0.65. I'm going to do this to 3 significant figures because that's what they've given us. So 0.37 over 0.31, that is 1.19 to 3 significant figures. 1.19 moles per dm cubed. 65, 2.0, 2.10, 1.87, and then 1 minute left. Okay, I've got to really hurry up now. 3.76, 12.1. But then I've got to put that now into our equation. Again, they would give you more space, but it just is what it is now. 1.19 by 2.1 all over 1.87 over, sorry, times by 12.1 squared. (9.08 times 10 to the power minus 3). 9.08 times 10 to the power of minus 3. Cancel. Moles to the power of minus 1. Sorry, moles minus 1 dm cubed. I've unfortunately run out of time to do the last question because I've been talking way too much. I should have just aimed on doing this, but I mean, yeah, try and not talk as much as me, obviously, but yeah, I'm just going to do the last question anyway. I don't really care. Structural acetal formed by the reaction of ethanol with ethane 1,2-diol. Acetal. And then technically this goes and does that. So it's more like something like that. Anyway, yeah, so I went over time anyway, but try to put a box around this actually when you're doing an actual exam. Man, I don't know, man. I didn't even revise for this shit, man. But anyway, I'm gonna get the mark scheme here. Oh, actually, let me make sure that there's nothing else on here first before I. Oh no, it's nothing. Good. All right, so gonna go back to question 1. I'm gonna mark this, and then I'm gonna go to bed, and you're gonna leave me alone. All right. Can you see that? Okay, so the first one. One, two, three. You idiot. And that's why you don't do your exams when you're tired. You gotta even count up how much you're meant to have. Just lost the mark on that because you're just an idiot. Oh. Would have been correct if I actually counted it up. But luckily I'm going through the mark scheme first before telling you to do the completely wrong thing to do. There you go. Oh, well, I just done it in normal pencil, but you know I didn't do the right thing anyway, but yeah. Anyway, expose the sample. Right, let me just do this. Is this there? This here. Expose, alright, so use plain polarized light. Expose the sample to plain polarized light, fine, yeah. Rotates in opposite directions or rotated in opposing directions. It's technically equally opposing directions, but it is what it is. I know you can't probably see this. Actually, let me get my viewfinder up so I can see what you guys can see. Push this way up. So you guys probably can't see what this is. I mean, you can zoom in on YouTube actually, so you can see more clearly. But that is the same thing. These are the same thing, so I can give myself that. Happy to say I got these correct. So I just lost one mark because of excuses that I have in life. One circle carbon atom only. That's the one. This one, the one. This is the one that they're referring to here. 2,6 for amine and amide. Great. Was I correct with this? Yes, I was. They never said draw the display formula, so I don't have to do that. They never said draw the display formula anyway, as far as yeah, so that should be fine. I don't see a problem with that. Choosing the correct bond. So choosing the correct bond first, that's a mark. Then saying, then drawing the 2 correct structures. So that's fine. All right, the next one is the enzyme has an active site. The active site on the enzyme. The active site on the enzyme is complementary. Chemistry. Enzyme has the complementary shape. Enzyme is complementary to isomer G only. I should say complementary shape. Has a complementary shape. Or I could have said correct stereochemistry or stereospecific. Or stereochemistry, so slash the stereochemistry. But I was along the right lines here with it being complementary to isomer G. Complementary shape to isomer G. To binds and hydrolyzes. Well, I didn't actually have to mention this last part here. But the active site on enzyme, yes, that's marked. It's complementary in shape to isomer G, only so they can bind to isomer G. All right. I'll give myself only a mark. I have to be fair to myself. So that is again 6. Again, this shows you that I know I've already done my exam, so I have an unfair advantage. But if you know the content really well, really well, these questions will be easy. And the way you know you can answer these questions well, it's all right knowing the content really well, but if you can't answer exam questions, it's pointless. You've got to do these exam questions to know that's the best way of knowing how to answer the question. Because if you can answer exam questions, it means you know the content well. Because you can know the content well, but not know how to answer questions. So yeah, that's all that matters at the end of the day. No one's doing a chemistry speaking exam for you. It's just about you're only doing an exam paper. That's all they see. 2-hydroxy hexane nitrile. Expose sample to plane polarized light. Plane polarized light. Each enantiomer will be rotated in opposing directions. Yes. The cyanide group will attack either side of the planar carbonyl group. Planar carbonyl group, that's a mark. Attack from either side. Attack either side. With I forgot to mention that. Yes, I should say. The cyanide group is equally likely to attack. That's why I lost my. I remember reading this. And if you have a timer, if you wasn't talking like this and you just did it straight, you know what? The next one I'll do, I won't talk. I'll just go straight through it, so I have enough time to go back and look at these questions. But you should be able to go back and look about, because I remember looking at this question saying there's something not right. So is equally likely. I usually say the cyanide group is equally likely to attack either side of the planar carbonyl group, producing an equal volume of either an enantiomer or the same chiral center in the mixture. So 2 here. Yes. There's no chiral center. 7. We're only losing 1 mark at a time, so I mean that's not too bad. D. 3 and chain. Do you need both of those to get the mark? Or actually, why is there no one? Okay, there's another one here. I don't know why they didn't represent that. Expose, and then doing this now. So again, you don't need to have the exact. As long as you have one 3D enantiomer, it doesn't have to be the exact one as this one. As long as you represent one 3D enantiomer, it can be any of the compounds showing that so this would be fine in your exam. What I've drawn you here, as long as you show a 3D example. Because the reason why this is acceptable, because you're thinking the mark scheme here is right. They would give you this. They've just given you one example because this compound is in 3D shape. This is one way of observing the compound in 3D shape, and this is another way of observing the compound in 3D shape. I.e., what I mean is, you can look at this pen from this angle, right? For example, but somebody else can look at the pen from this example, and they're both correct. If I drew out this pencil in 3D and drew one like this and one like this, they're both the same thing. They're both representing the same thing. I'm just viewing them from different perspectives. But what I've drawn here, make sure I've done one 3D enantiomer, and I've done a second enantiomer correctly drawn as a 3D mirror, and this is exactly a 3D image, a 3D mirror image of this. So I've done that as well, and that's my 2 marks. Expose sample to plane polarized light. Rotated in opposite directions. Rotate opposing directions. Elimination. So the first mark is going to the H plus from the lone pair hydroxyl group. Then it's going the color arrow going from the bond, the color arrow going from the bond between the carbon and oxygen towards the oxygen. Yes, there. And another one showing this intermediate here. You're showing this intermediate here. That's one way. But1-ene is here. So I should have labeled this but1-ene actually. That's my bad for not labeling it as but1-ene. But I don't think you don't actually have to. But but1-ene, but2-ene. I've gained my 1, 2, 3 marks from that. The second intermediate carbocation shown and an arrow of carbon hydrogen we've lost to form this. So showing you're forming that as a mark or in some way form, either in this one or this one. And find its explanation. So loss of hydrogen from carbon in the carbocation adjacent to the C plus, so that's carbon 2 or carbon 3. They will, with these wording, they will allow ways of wording it because they know you mean the same thing. So adjacent to the carbocation, i.e. you're saying here carbon 3, carbon 1, those are the only 2 examples here. Even names here, carbon 1. So if it's from carbon 1, it'll be but1-ene, and I did mention that. And if it's from carbon 3, it'll be but2-ene or EZ-but2-ene. So here, carbon 3, carbon 1, 1, 2, 3, 4, 5, 6, 7. Oh, loss of the hydrogen. 8. Good. Nearly done. 7D. Again, if you don't know why I've done 7D, I tried to explain it whilst I was answering the question. But if you ever need any help, just leave a comment in the description and explain. Leave a commentary in the comment section or in the description. Nucleophilic addition. The 2 arrows from here to, that's 1, and that's 2. A mixture of an equal mixture, so equal volume. They say OWT, so that would have been something to do with the way you word it. They will allow you if you have the way you word it. So equal volume of each enantiomer of the same chiral compound. Yeah, a mixture with an equal volume of each enantiomer of the same chiral compound. I said enantiomer here. Equal. These are just even tying equal there, so gets you the mark. Non-superimposable. You don't have to say the word non-superimposable. Just mirror image is fine, but non-superimposable is you know, super. 0.33, 4.16. Great. You could have just said acetal with name. So, but I've done it here anyway. I've mentioned that's a square there. Good. So either way we're doing it. I've actually done, if I've done 1.19, that's the same as saying 0.37 over 0.31. You showed what how you got to 1.19 here for acetal, for example. So this here is the same as doing that there. So don't worry about that. You would have got the mark for that. Anywhere between 9.08 times 10 to the power minus 3. And then saying the correct unit, so moles to the power minus 1 dm cubed. Why? Because that's on the top is squared, so it's moles per dm cubed times by mole per dm cubed. That's moles squared per dm to the power of minus 6. And then over moles per dm cubed times by moles per dm cubed, moles per squared per dm cubed. So that in hindsight, this cancels out the entire numerator in terms of the units. So you only have this denominator here, which is moles per dm cubed. But it's 1 over. Essentially, what we have is 1 over moles per dm cubed, which is the same as moles to the power minus 1 dm cubed. right? That's 4 marks there. Here it is a what I've drawn here. Oh, it's not. It's not the same thing. I've done something completely different. Right. Well, it's not. It's whatever this cunt is. All right. That. All right. Cool. Great. $11. Great. There you go. Does anyone really care about me stacking up my marks? You already guys know I already have my A-level. Do I really want to count my marks up? I do want to count my marks up because I am the GOAT. Allegedly, rumors say it. I didn't say it, someone said it. That's it. The video's done, by the way. I'm just doing this for me. So if you want to stay behind, that's up to you, innit? But personally, I just cut. Because if you stay behind for this, I think personally, if it was me, I'd just say, yo, moist, innit? If you actually stay behind for this, you're actually moist. You're still here. Man, cut, bro. You're actually moist, bro. My life, these guys, man. Oh my days. All girls. I can't discriminate because, 2023. I act like there wasn't girls doing A-levels back in the day, but, it's, man, the ones where, you're not trying to catch a case, but you're catching a case. I'm just talking to you guys right here, you know what I mean? I'm just trying to count all of this up, but how are you guys? That's the real question is, how are you guys? You know what I mean? That's the real question. As long as you're, say, 46, see, tell me who's more accurate than this. The only person I know that's more accurate than me right now is Eric Ten Hag. Apart from that, no one. Tell me one person in the game right now that's doing what I'm doing. And before you start saying, I know someone that's like, shut your mouth, man. You're talking nonsense, man. Alright, cool. So, by the way, man, you mentioned just like, fuck off right now. Fuck off.